So good morning everybody, myself Acharya Vishvendra, and today I'll discuss a worksheet on kinematics of circular motion. So we have a particle moving on a circle of radius r, and the angular acceleration is a function of time, t square radian per second square, and initially angular speed is 0. So the first question is we need to find omega as a function of time. So using first equation, omega is equals to integration alpha dt 0 to t plus omega naught. We have alpha is t squared dt, so that will reduce to t cube by 3. Then we have to calculate angular acceleration alpha at t is equal to 1. So in this equation, substituting t is equal to 1, we have, alpha here is t square. So t is equal to 1 gives us alpha is equals to 1 radian per second square. Then we need to find alpha at t is equal to 2. So that will be 2 square, which will be 4 radian per second square. Then we have omega as a function of t. So this we have calculated as t cube by 3. Then we have omega at t is equal to 2. So that will be 2 cube by 3 or 8 by 3. Then we have omega at t is equal to 4. That will be 4 cube by 3 or 64 by 3. Then we have a question related to expression of omega. So we all know that if alpha is variable, then omega is omega naught plus integration alpha dt. Whereas angular displacement is given by integration of omega dt with the limit 0 to t. And this is third equation of motion, which gives omega square is omega naught square plus twice integration alpha d theta. In the next question, we are being given alpha as a function of theta. It's theta square plus 4. Unit is radian per second square. We need to find alpha at theta is equals to 2. So if theta is 2, then alpha will be 8 radian per second square. If we see the graphical variation of alpha versus theta, so it will be a parabolic variation like this. Then we need to find if omega naught is 0, we need to find omega at theta is equal to some theta. So we use third equation of motion, which is omega square is omega naught square plus twice integration alpha d theta. So omega naught here is 0, alpha here is a function of theta. So after calculations, we have this as omega. Then we need to find omega at theta is equal to 2. So in this equation, substitute theta is equal to 2 and omega will reduce to this thing, twice of root 32 by 3. Then we need to, in a certain question, we are being given graphical variation of alpha versus time. So this is the variation and this is 10 radian per second square. This is 10 second. So we need to find alpha at t is equal to 0 seconds. So it's given by 10 radian per second square. Then alpha at t is equal to 10. It's evident from the graph that it will be 0. Then we need to find alpha at t is equal to 4. So in this triangle, here is 4. So we can say that alpha here, this thing will be 6. So alpha by 6 is gonna be equal to 10 alpha. And take this angle as theta. So this will be 10 theta, and from the diagram we can see that this thing is 10, this thing is also 10. So 10 theta is gonna be 1. That means alpha is gonna be 6 radian per second square. Then is a question that if omega naught is 10, we need to find omega at t is equal to 2. So for that we need to use the first equation. Omega is omega naught plus integration alpha dt. Alpha dt integration from 0 to 2, that is equal to the area of the triangle or area of the figure, and this is a trapezium over here. So here it is 2, so here it will be 8. So we can say that here this thing will be 8 and this thing will be 10 over here. So we are going to calculate area of this trapezium will be half into 10 plus 8 into 2. So that will be 18. So from here we can conclude that omega will be 28. Then we need to find omega at t is equal to 4. Using the same tactic, we can write omega is 10 plus half. If t is 4, then this thing will be 4 and this thing will be 6. So we have, and if this is 6, this is also 6. So triangle would be like, this thing. So here it is 10. Here it is 6. And here it is 4. So we have finally omega is 10 plus half. Area of trapezium will be 10 plus 6 into 4. So that will be 32. So that will give us 42 radian per second. If you have any doubt, you can ask in the comment section. Thank you and have a nice day.